Hi there and welcome to our first live online lecture in Java. Now unfortunately when I was doing the live online lecture I forgot to press record, so I didn't record the actual lecture, so I had to do it out again. Now this is what you will see, but it's exactly the stuff that was recorded in the online lecture. Okay, it's exactly the same. Alright, I didn't put the files up quite yet. I will after I finish recording this because I want to make sure they match. Alright, so we are going to start. Now this is just the stuff we covered last night, but I'm going to do it again. So we are in our Eclipse. So I go to up here, I go to File, I go to New, I go to which one do I want? I want to get a Java project. If you don't see it there, click on Other and you type in Java. You should see Java project come up there. Click on that guy there. Click on Next. Okay, so project name. Now the name I'm going to give it is Chap 1.1. I'm going to call it Intro. Okay, that's going to be the name of our project. So I'm going to type it in there. So it's CHAP 1.1 Intro. Okay, you don't have to bother with anything else. Okay, just click on Finish. You don't want a module. Okay, so we now have our Java project created. So here in our Package Explorer, this is where all our projects are going to appear. All right, so you click on this guy here, we can see that we can open up our project and have all these little things inside it. Do not mess with the GRE system library. Leave that there. All right, so the first thing we're going to do is we're going to create a package inside of this project. So right click, New Package. Okay, now I'm going to call this package, write it up here so you can see, com.android. Now the reason we're going to call it com.android is if you're developing apps for the Android operating system, which is any phone that's not an iPhone, they all use Android, you need to have something called a package inside it, and that package inside it needs to be called com.android. All right, so if you're releasing anything to the Play Store, you need in your application the code has to be enclosed in something called com.android. So I put it in here underneath name. So I'm going to put in com.android. Click on Finish. Okay, so we can see up here again we now have a package. Okay, so we now have a package. So I make sure you right click on the package com.android, right click, new. I'm going to call, see, click on class. I'll do that again. Right click, new, class. So the class I'm going to call it main. Okay, I'm going to call it main. So I go M-A-I-N. So I just put it in there in the name. Okay, that's what I call it, name. And we're going to click on this guy here. Public static void main. You click that tick box. Okay, click that tick box. So then we click on Finish. And there we have our file created. Now, as I said, everything in Java is based on classes. So all of our code is going to be written inside. So we have two sets of brackets. Okay, there's this bracket and this bracket. Now, for every opening curly bracket, you have to have a closing curly bracket. So this is something called a class. Okay, and inside that class, we have something called a main method. All right, and we can see that's the opening bracket, that's the closing bracket. So for the first 3 or 4 lectures, everything we do is going to be inside here. Okay, so all of our code is going to be inside the main method. All right. Now, so where does our code go? Our code goes here. Okay, that's where our code goes. All right. So the first thing we need to do before we actually do any coding, we need to do something that are called comments. As I said, I'm not going to be doing out separate notes. Our notes are going to be in the middle of our code. All right. So as you're coding, you're going to see your notes. Now, comments are something that are ignored by Java. All right, simple as that. They're ignored. So whatever sort of coding you're doing, you need to put in comments. All right. This variable is the age of a person. This is a application to get your perfect match on Tinder. All right. So you can't over comment. The more comments, the better. Now there is 3 separate different types of comments. The first one is a single line comment, and it's that guy. It's the // So this is a single line comment, and the text is ignored. Okay, so that works fine. Okay, now the other type of comment, so I'll just go down here, so it's /* press enter. Now, so this is the opening of your comment, this is the closing of your comment. So anything between the opening / and the closing / is considered a comment. So that is ignored again by Java. So this is, so just get rid of that guy. Go to here. So this is a multi-line comment. Anything between the opening and closing / is ignored by Java. And here is a comment. Now, because, let me just show you, if I type up, hello there, nice to meet you. Okay. Now, Java treats that as a line of code. And when you have a line of code that causes errors, you'll get this guy. All right. Now, these are something called compiler errors. So Eclipse can pick them up. And what you get is a red circle with a white X inside it. Okay. That means it's something called a compiler error, and your code won't run because Java says, right, so this is not a comment, this is code. All right. Now that is just English, normal English. So that is not going to compile. Okay, there's 2 stages when you're running a Java program. First thing it has to do is compile it, then it runs. Now Eclipse does all this automatically for you, but there is 2 steps going through when you're running any code. It has to compile itself, and then it has to run. Now Eclipse does this all automatically for you. If you didn't do that, you'd have to run 2 commands. One of the commands is called javac, another command is called Java. But we don't have to run them because Eclipse does it all automatically for you. All right. So as well, when you get a compiler error, you can see that it attempts to see where the errors are. Okay. It doesn't recognize hello, nice to you. It thinks that there might be a Java keyword, and meet would be a Java keyword as well. Okay. There is some obscure command somewhere that uses that word for something. There is some obscure command somewhere in Java that uses that guy, but all the rest of them, it doesn't recognize it, so you get errors. If you want to take them out, you comment. Okay, so you can see no more errors. So you can see, as well as putting in what your code is doing, it can, in such a, it can, what your code, what it will do is it will comment out your code, so your code won't run. Okay, that's not code, so it wouldn't run anyway, so I'm going to take that guy out. Right, so this is a multi-line comment up here. This is another multi-line comment. Now, so I'll do that again. It is /**. Now this is something called a java.comment. Now what's a java.comment? This is a multi-line comment that can be used to produce a document automatically. And more text here. Okay, so you can run a specific command, or it's an actual add-on that it will search your Java code for these guys, and from that it will produce text document. It could be WordPad, it could be Notepad, it could be Word document. Okay. Now, so as I'm going along, everything I do in Java, I'm going to put in comments. All right. So these are the notes are going to be. They're like active notes. So we do a bit of code. I comment what this code is doing. Okay. When I come to if statements, which we will come to next week, I will be saying this is an if statement. This is how it works. All right. So everything is going to be commented. All right. So I will take out that. Scroll down the screen a bit here. Now, the first thing we're going to do is we are going to do a print statement. Okay, so the print statement is system dot out dot print. Now, as you can see, as I'm typing, so it's capital system dot out dot print. As I'm typing, you see, it's even doing all of the, it could do all the typing for you, believe it or not. All right, now every line of code, finishes with a semicolon. Okay, every line of code finishes with a semicolon. All right, now this is the command that we use to print out a line of text. Now, a line of text in Java is called, take out that guy. So a line of text, or a word in Java is called a string. Okay, so a string refers to a piece of text. All right, now, so the format is as follows. So this is something called a method here. Okay, system.out.println is how you can pronounce it, or sysout. All right, this will print off a line of text, and then it goes on to the next line. Now, what happens is, I'll actually make this a bit bigger, so we'll zoom in on it. All right, so we zoomed in on it there, so we can see these are our braces. The braces there. So whatever we want to print out, we put inside the braces. Now, if we wanted to print out a piece of text, we surround the piece of text with double quotation marks. Okay, you surround the piece of text with double quotation marks. So quotation mark, quotation mark. All right, you only have to type once because Eclipse puts into them automatically. All right, so in between the double quotation marks, I'm going to type hello there and welcome to Java. All right, now, so this is our print statement. We have our braces, and inside our braces we have two quotation marks, and inside the quotation marks we have our string. The quotation marks tell Java that this is a string, so this will print off hello there and welcome to Java. Now, where will it print it out? It'll print it out here. Okay, this is your console. All right, now there are so every time you want to run some code in Java, you have to first save it. So you save it and you run it. Okay, so that's what you have to do. So every time you run some code in Java, you write some code, you have to save it and then run it. Okay, so every time you do something in the code, you save it and run it. Now, there is, first of all, I'm going to show you the long way to do it. So I will go up to, I'll make this a bit smaller again. Okay, get rid of this guy. And I go up here. So I go to File. I go to Save As. Oops. A minute now. So I go to File. I go to Save. Okay, that will save it. Then I go to this little icon up here. All right, this is the run icon. So I click on this guy here. It's commonly, you've seen that icon before. You'll see it on remote controls and televisions, for instance. It means play or whatever. Okay, click on that. Now we can see now that this code, so that this code produces less printout. Okay, I'm going to do another line of code. I'm going to go system dot out dot println, and this is our second line of code. Now, every line of code finishes with semicolon. Okay, every line of code finishes with the second semicolon. So we can see this is our second line of code. It's inside the double quotation marks, it's inside the braces, and at the end of that we have a semicolon. So every valid line of code you have in Java is going to have a semicolon. If it doesn't, you'll get an error. Let me just show you. So if I take out this guy, all right, we can see we have our red circle with a white X inside it. It's even telling you there. Now, if you click on it, sometimes it'll tell you what the error is. Okay, so if I go to here, syntax error, insert. So I'll do that again. Put my line over it. So I'll zoom in. Syntax error. Sorry, I'll do it again. Syntax error, insert the semicolon to complete the statement. All right, so I'm going to put it in. Now, more often than not, it's not going to tell you how to fix your code. All right, it's not that smart. All right. Now, so again, I go File, I go Save, I go to the Run, and it runs. Here's our second line of code. So, whoopee, we run 2 lines of code. Now, rather than going File and then Run, there is a shortcut. Now, there's many shortcuts you can do in Eclipse. Now, so this is our third line of code. You can see the little red mark there. Now, instead of going up to the menu here and going Save and then going to this little icon here, there's a shortcut. Okay, there's a shortcut you can type on your keyboard. Okay, now the shortcut is Control plus S is to save, Control F11 is to run. All right, so I am going to, I'm on my keyboard now. I press Control. Control is to either to the left or to the right of your space bar. Press Control, then I press S. My file is saved. Oops. So Control S. Now you'll notice up here as well at the top, see the little star. That means it's not saved. Okay, that means it's not saved. The little star that's beside your main. See the little star there. Okay, so I am going to save it. Okay, so I go Control S, the star is gone. Okay, so it's just a little reminder that your file isn't saved. So I have it saved. Now I press Control F11. So before I do it, look down here. Control, turn off my righty. Control S, Control F11. There's our third line of code. Okay, so as I'm going along, I'm not going to be bothering using this guy up here. I'm just going to be Control S, Control F11. All right, so to save it, Control S. To run it, Control F11. Now, so I'm going to put in another line of code here. Now, as well as a shortcut for saving and running, there is also shortcuts when you're writing out. Now, this guy here is called a method. All right, it's actually something called a static method. Doesn't matter what it is, it's just a command for now. All right, it's a command. So it's the command we use to print out. Now, there is a shortcut. Rather than going system .out.println, right? There is an easier way to do it. Okay, the easiest way to do it is type in syso. Okay, then you press Control space. Oops. Okay, hold on. Give me a second here again. Right. So I need to do that again. SYSO. Yeah. So I'll do that once more. So it's SYSO. It's Control space. All right. So Control space. So you type SYSO. Then you press Control and space. All right. So I'll do it again. I'll get rid of this guy. And I go SYSO. Control space. There it is. Now you have to keep your finger on Control. All right. You have to keep your finger on Control. SYSO. You can't press Control and then press space. So it's Control space. All right. So you have your finger on Control and then you press space. It'll automatically type in system.out.println. So what is that going to put in? That's going to put in a blank line. Okay, so that's a blank line. And the next one, I am going to say SYSO. This is going to be, oops. Here is some text for our fourth line of text. All right. Now I'm going to put a comment above this explaining how this works. Now, this is how we print out a piece of text. All text has to be inside the opening and closing brackets, and all text has to be enclosed in double quotation marks. Every line of code has to finish with a semicolon. Control S will save the file. Control and F11 will run the file. Every time we use system.out.println, we're inserting a new line. And as well here, to use type SYSO, then press Control plus space to automatically insert this guy. All right. That will automatically be inserted. Make this bigger so we can see it. This bigger so we can see it. Okay. Now, so nothing too difficult there. Now, we've seen how to print off strings. Now, these are what are called strings. So text is called a string in Java. All right. And most programming languages is called a string. All right. Now, so if I come along then, and if I just type in 45. Now, I don't have double quotation marks around 45. So when I put in a number, that is treated as a number. All right. And what does that do? Oops. It prints off 45. All right. So, as I said, when you don't use double quotation marks, around numbers, Java treats them as numbers. So this will print out 45. Okay. Now, as well as knowing numbers, Java knows addition. Now, if I came along and I printed out hello, that's an error. There is no command called hello. We'll be doing them later on. Variables. There is no variable called hello there. So that gives us an error. All right, that's just a piece of text that doesn't have double quotation marks around it. So I'm going to put in 12 plus 30. Okay, so Java knows all the mathematical operators. So it knows additions. This will print 32. This one. This is going to be 12. Now the multiplication symbol is that guy. I'll multiplied by 30. So this is multiplication, and we'll print out 2760. All right, now division. We go 30, now the division symbol is this guy, /. 30 divided by 3. So what is this? This is division. Now, see, you can put a comment at the end of the line as well. This is division symbol. This will print out 10. And finally, we'll do subtraction. Now, as I said last night as well, don't be put off by the fact that I'm doing numbers in the first lecture, right? It's not really that mathematical at all, believe it or not, right? It's just that these are what are called the primitive variables. I'll cover what those are in a second. So we have 30 minus 12. Okay, this is subtraction. This will print out 18. So Control S it, Control F11. So we can see it's print of, oh, that's 42, not 32. Jesus no. Okay, so there is, that is 42. This guy is 12 by 30. It is not 200, it's 360. Where am I going with that? Okay, oh, it's a Friday. So that prints off 360. Okay, we have division. 30 divided by 3 gives us 10. 20 minus 12 gives us 8. Okay. So, now, that's great. Now how long does it know all these operators? It also automatically knows precedence. Now, what do I mean by precedence? So at its simplest level, you have multiplication, division comes before addition and subtraction. So if I got 2 plus 30 divided by 2, now what happens there is it does the division first. So we have 30 divided by 2 gives us 15, and we add 15 onto 2, and that gives us 17. Okay, so I'll print that out. 17. Now, so what does it do? Java knows precedence of operators. Alright, so you can even do something more complicated. A more complicated version of it would be, go here, SPSO, and I go 2 plus 30 divided by 2 multiplied by 3 minus 2 multiplied by 5. So that's 30 divided by 2, which is 15, multiplied by 3, which is going to be 45. Okay, no, that's wrong. We'll see what it prints off. Let me just have a look. It prints off 37. Okay, 30 divided by 2 is 15, multiplied by 3 is 45. I've done something wrong there. Okay, I have done something wrong there. I don't know what I've done wrong, but I've done something wrong. Oh yes, I know what I've done wrong. Alright, so it is 30 divided by 2, which is going to be 15, multiplied by 3, which is going to be 45. Okay, then we have 2 multiplied by 5, which is 10, so that's 45. So you end up with, for that, you end up with 45. Then you have 2 plus 45 minus 2 multiplied by 5, that gives us 10. So you have 2 plus 45 is 47, minus 10 gives us 37. Okay, so Java knows precedence. Okay, so close off that guy, and that gives us 37. Now if you put a number inside double quotations, Okay, so this prints off 37. 37, and this prints 30 divided by 2 is 15. Sorry, it's 15 plus 2 is 17. Okay. Now, so when you put anything in double quotes, even a number, it's no longer a number, it becomes a string. So for instance, if I go SYSO, put in a string, I go 2 plus 3. Now this is no longer the number 5. Okay, so put it in here. When you put anything inside double quotes, it becomes a string. So this will print out 2 plus 2 plus 3. Okay, so I'm going to show you. There it is. Okay, it's no longer a mathematical equation. It's no longer 2 plus 3. It's just a piece of text. Okay, and it's treated as a piece of text. Similar if I did the same with multiplication. 12 multiplied by 12. What's this print of? Prints of 12 star 12. Alright, and let's show you the difference. Whereas 12 multiplied by 12, this is a number. Print of the number 144. Okay, now all of this up here, these are what are called, everything we've done so far, so the above are hard coded values. Okay, now instead of hard coded values, all programming in every language, well, practically every language, relies on variables. Okay, now, so a variable is made up of 3 distinct parts. Okay, a variable is made up of 3 distinct parts. Now the easiest way to show you is to show you an example. So I go int num is equal to 12 semicolon. Alright, now every variable you ever create in Java has to be given a type. Okay, now other programming languages such as Python, such as JavaScript, such as PHP, you don't have to give them a type. With Java you do, with C# you do. Personally, I think it's always an advantage to give them a type. Now all that means int means that this variable can only hold a whole number. A whole number that's going to be plus or minus 2.1 billion. Billion is that guy. 2.1, so 100 million. That's a billion. That's 2.1 billion. So plus or minus. All right. So it can go from minus 2.1 billion to plus 2.1 billion. Now 0 is not nothing. It's just another number. 0 is the number between minus 1 and 1. Okay. So we're saying that this variable is going to be an int. It's going to be a whole number. All right. No decimal places allowed in ints. Now this is something called a reference. Now reference is simply the name of the variable. All right. So every variable you have is also going to have a reference. A reference is quite simply the name. Then you have, sorry, it's 4 parts in a variable. Then you have this guy. Now that is not the equals to sign. That is the assignment operator. Okay, that is the assignment operator. And finally you have value. Now, so what we're doing is we're assigning the value 12 to the variable num. Okay, we're assigning the variable 12 to the value num, which is of type int. It can only take whole numbers. So what does that mean in practice? It means we can now, instead of using the number 12, we can use num. All right, so let me just show you what I mean. All right, so I will go here. I go so I go num. See, it prints off 12. All right, it prints off the number 12. So I'm going to put a comment in for variables. So I have it all here done out already, so I'm just going to copy it across. Just give me a second. Copy it here. So control here and put it in here. So when we first declare variables, we have to supply a name and a type. Here we give a variable a type of int, which is an integer, which is a whole number, no decimal places between minus 2.1 billion and plus 2.1 billion. The name of the variable is num. Okay. We also have an assignment operator. We use the assignment operator. So I'll show it here. We use the assignment operator which is this guy, to give a value of 12 to the int num. Okay. Now, beauty with this, of course, is that variables are by their very name. Variable means it can change, and that's exactly what you can do with it. All right, so this prints 12. Now I'm going to change num. Now, from this, you can change values of num. I don't put int in front of it again. All right, don't do that. All right, you only have to define this type. Now, when you define a type, it's stuck with that type. It can't change it to a string. You can't change it to a character. You can't change it to an object. So that means that num can only be, think of it like a bucket. All right, now ints have got a set size. Ints are 4 bytes in size. Okay. There is another type called a double. Now, double is decimal places. That takes 16 bytes. Now, it doesn't matter whether your int is just the number 1 or if it's 2 billion. It's still going to be the same size of 4 bytes. All right. If you have a double, let's say 2.1, and you have another double, 366,006,777. Doesn't matter if it's that number or that number. It's always going to be 16 bytes in size. All right. Once you define the type, you can't change it. The type is set in stone. All right. Now that is actually a good thing. It makes a small bit awkward at times, but it is a good thing. So you know that this variable, its value can change. Okay, value can change, but its type can't. So I mean, so num. So this prints 400. There we have it. So we can see here, it's got the value 12. Here, it's got the value 400. Now, in every programming language you're going to be using, your variables value, so any application you ever develop, your variables are going to be changing perhaps millions of times in a second. All right. I just had Spotify on there a minute ago before I started this, listening to some music. There's variables being changed there the whole time in Spotify. There's thousands of variables changing thousands of times in a second, even millions of times in a second. All right. So variables are made, their values are made to change. Their values can change, but not their type. Okay. Int num is going to be an int from now to the end of time. Okay. Now, so the beauty of variables, you can use a variable then as you would a normal number. All right. So we can see up here we're doing addition, subtraction. Now a num, you can use it exactly the same as you can with a number. So I'm going to create another variable down here. I'm going to call it int num2 is equal to 900. Okay. Now I'm going to do a print statement. I'm going to say num plus num2. Now what's that doing is it's taking the last value for num, which is 400, and the last value for num2, which is 900. It's going to add them up. So what's it going to give you? It's going to give you 1300. Now the values can change. So if I change the values to something else, let's say 2356 or 23,456. Okay, and this guy here is 92,000. Okay, so you add up those two numbers, you get that number there, which is 115,456. All right, it's a big number, but I'm going to bring it down. I'm going to bring it down again to 400 and 900. Okay. Now, and you could do multiplication. There we are. You can do division. Now, I'm not going to do division yet because division causes an issue. Okay. Now, so I'm going to go here. Can't have a number. So when it's an int, can't have a number greater than 2.1 billion. Approx. Now, I'm not sure the exact number. You don't need to know it really. So if I go num is equal to 2, I got 3. So I go, a billion is 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We got an error. Why? Because an int can't take that big of a number. It can take 2 billion. So I'll just 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, as I said as well last night, so can't take that number. All right. So what it can take though is 2 billion. 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works fine. Okay. So this guy here will not compile as the value is greater than 2.1 billion. Okay. You also can have minus numbers. So num is equal to minus 23. Okay. Nothing great. And it can go up to 2, I can go down to minus 2.1 billion, but it can't go any less. Okay. Great. Now, so we next came to concatenation. I'll just pause this for a second because I need to take a drink of water. Now, the next thing we're going to do is we're going to do something called concatenation. Now, concatenation is based on this symbol. Now, when you have two numbers, that's treated as addition. Okay? If you use that guy with a string, it's considered to be something called a concatenator. What a term. Now, concatenator, think about gluing pieces of text together. That's what a concatenator is. So if you use it with numbers, it's addition. All right. If you use it with strings, it's something called a, if you use it with a string at all, it becomes a concatenator. Let me show you what I mean. So I'm going to go down here, give myself some space. Yeah, so I am going to go, I'm going to give a new value to num. Num is equal to 900. All right. So I am going to go, put in a string. Num is, now put in a space, I go plus num. Now that prints off. So what we're doing here is, now when you're putting in multiple items in a print step together, you have to use this symbol. All right. Now if you use the symbol with a string anywhere, that guy becomes a string as well. Now I'll show you what it means in a second. So that will print off num is. Now you can't just do that. That's an error. Okay. Other programming languages allow you to do this. Can't do that either. Okay. Now, so what you have to do is you have to put in the plus symbol. Okay. And that will print off num plus 900. Okay. Now, I'll put num2 here. Now, I go on to my next line. Oh, sorry, no semicolon. Now, if I go here, that's why I saw. I say my nums are. I go plus. Oops, that should be num2. Plus num plus num2. Now, because this guy is a string, that is treated as a concatenator. So what does it do? It turns all of these guys into strings as well. So it just takes, puts in 900 here, and it puts 400 after it. It doesn't add them up. So that this will print off my nums are 900, 400. Let me just show you. There we are. It's printing off 900, 400. Okay. Now, so I put it in here. Num, which is 2. So put it up here. So where are we? This guy. So take out this guy. So I'm going to change the value of num to be 120. Okay, so that just matches what we did last night. As plus symbol after a string. So I will take this back to here. Oops. And put this back to here as well. And
have you the child's top?
so sorry about the child's top. So when you put a plus symbol, so that we have a text and followed by the variable num, which is 120. Okay. Here. So here, this prints out my nums are. So num is 120. Num2 is 400. Okay. Here, this prints out my nums are 120, 400. Why? Because they're considered, when you're using the plus symbol after a string, they all become strings. All right. If you go on to do the Oracle exam, that's something they always ask. All right, they always ask that. It's they try to trick you into thinking, oh, I added up 120 and 400. That gives us 520. It doesn't. It gives you. Hold on, just take it out. It gives you 120, 400. Okay, which is that guy there. Why? Because it's just printing off, it's converting them to strings automatically. All right, now, so what, I'll just do another one down here. So if you just have two numbers, so we go plus 12 plus num. So what you get there is 12 120. All right, so this prints off here. So this guy here prints, go here, two numbers, 121 120. All right, so now what do we do if we want to do some sort of calculation? Okay, now, so I'm going to go down here. I am going to give new values. I'm going to go to num. It's going to be equal to 120. Num2 is going to be equal to 900. All right. Semicolons at the end of it. Semicolons at the end of it. Now, so I am going to, so we have our two numbers here. So what happens if we want to add up those two numbers? Because you can see if you just put in the plus and the plus, it's going to treat them as strings. So what you do is you put in another set of brackets. All right. So if I go here, the sum of our two numbers is, so I go plus. Now put in more brackets. I go num plus num2. Okay, I go num plus num2. Now the general rule is where you have brackets, you do the inner brackets first. So what do? You add up num and num2, their numbers. So you add up 120 and 900, you get 1020. Then this becomes a concatenator. So it puts 120, 0 to 0. So it prints off the sum of our two numbers is 1020. There it is. So we can add, so I will put in the comment for that. So the comment for that is, the mouse after disappearing. Oh, it's back again. So comment here on my other screen. Put it in here. If you place two numbers and a calculation, another set of brackets, the calculation will be treated as numbers and then added to our text. Rule of thumb across all of Java is do inner brackets first. Okay, let's do inner brackets first. Now there is an alternative to using this. All right. Now I am going to create another variable. I'm going to call it sum is equal to num plus num2. Now you write your programming left to right. All right. When you're using assignment operators, when you're using these assignment operators, you do the right hand side first. Okay, so what you do is you add up 120 and 900 and you get 1020, and then you assign it to the variable sum. Okay, you add up 120 and 900 and then you assign that to the variable sum. So you do, when you're doing assignment operations, when you're assigning a value to a variable, you do the right hand side first. Okay, so what does that do? So when assigning a value to a variable, we do the right hand side first. Okay, so here we add num, which is 120, to num2, which is 900, and we get 1020. Then 1020 is assigned to the variable sum. Okay. Now, so this is sum will be 120 plus 900, which will be 1020. Okay, and so then if we just want to print off the sum, we go sum is plus sum. All right, it's neater than using that. You can use that, but I think that's slightly neater. All right, it's up to yourself if you want to use that in the future. Okay, and of course you can. All right, so just go forward here a bit. Now, I'm going to show you the different form of numbers. All right, the different forms of numbers. So, the different form of numbers are. Hold on a second here now. And as well, if I change num and num too. All right. So let's just say I change num here to 45,000. I change this to some infeasibly large number. Okay, now sum is going to be those two numbers added up. Okay, going to be those two numbers added up, but I'm going to change the back to 120 and 900. Okay, so 120 and 900. All right, I can even go down here. I'll change them to some two other numbers. Two other numbers are going to be 78. It's going to be 567. And then you can say sum is equal to num plus num2. Okay, I don't have to declare int in front of sum again, as I've already declared it up here. So then I can go SYSO. Sum is now plus sum. It's going to be those two numbers added up, which gives us 645. Okay, 645. Right. Now we're going to go through each one of the numbers. So just pause this a second. So I'll go through each one of the what are called the primitive data types. So the primitive data types are what everything in Java is made of. All right. So there is 6 different numeric types. I'll start with the smallest. The smallest is something called a byte. Okay. I'll put in the comment. So we go. There are 6 different numeric primitive data types in Java. Okay, first one is a byte. Now, byte can go plus or minus 128. That's only, as its name, it's 1 byte in size, I think. All right. So if I go byte, bnum is equal to 127. We'll vision it fine. Byte. So if I go bnum is equal to 128, won't compile. Okay, so byte is plus or minus 128. So it is plus or minus 128. Okay, this will not compile as only goes up to 128. Okay. Back, so it's a byte. Now, next one is short. Now, short is precisely plus or minus 32,000. So it can go as far as, now short would be 2 bytes in size. Okay, so this one is only a byte. Doesn't matter if it's 1 or 127, it's going to be 1 byte in size. A short is going to be, doesn't matter whether it's 1 or 31,000, it goes plus or minus 31,000. So snum is equal to, say, 31,123. Okay, However, if I go snum is equal to 32,000, but okay, 33,000. Okay, so it goes up. So if I go 32,500, okay, so it goes up to 33,000. Okay, change that again. 32,500. So it goes up as far as 32,999. Okay, I don't know. All right, approximately 32,000. All right, 32,500. So it's a prox. All right, so it's a prox. So if it goes up to 33,000, so all of these figures are a prox. Okay, approximately plus or minus 32. That's approx. I keep saying that it's a prox. Okay, so shorts. And the next type is an int, which we've already covered. So I call it innum. It can be plus or minus 2 billion, so I go 2. Now you can do this in Java. So you can't do this. Okay, that is actually something called an array. All right. Well, it's a list. If you're doing a list of anything in Java, you can separate them by commas. So what that actually is, it's the number 2 followed by the number 000, followed by the number 000, followed by the number 000. So if you want to do this, you can do this instead. That does compile. All right. So int innum is equal to 2 billion. So I should say here, this is, I think it's 1 byte. Now, I am open to correction on that, but I know it's the smallest numeric type. So it doesn't matter if it's 1 or 128, it's 1 byte. This one is 2 bytes. This one here is 4 bytes. Now, it turns out that by default, all whole numbers in Java are considered ints. So if I just go something like this, that 67 is an int. All right, that 67 is an int. If I put in a bigger number, that's an int. All right, so everything you do in every sort of variable or value you use in Java has a type. Okay, whole numbers by default are ints. Now the other type, so we have byte short int. Now the other type of whole number is something called a long. So long lnum is equal to. So this can take more than 2.1 billion. So I can put in 40, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, as all numbers are considered by default ints in Java, okay, you run into this problem. Any number that's greater than 2.1 billion, right? Java says, hold on, that's an int. You can't fit 40 billion inside an int. Doesn't matter that you're assigning it to this guy here, it's still treated as an int. Okay, so what you need to do is you need to tell Java that the value on the right hand side is not actually an int, because that's what it's treated by default. You have to tell it it's a long. So how do you tell Java it's a long? By putting an L at the end of it. Okay, so I'll just show you there. Okay, getting an error. So I'll put an L at the end of the number. Now it's treated as a long. Okay, so long is for numbers greater than 2.1 billion. Now long would be, so if an int is long, I think is around 8 bytes, I think. I'm not too sure. I don't know what it is. It's bigger than an int anyway. Okay, so it's more than 4 bytes. We'll say 6, I think. So this is, I think, around 6 bytes. Doesn't really matter. Just you need to know that a long is bigger than an int. Okay, so I think this is around 6 bytes. So now you can't assign anything with decimals to any of these types. So bnum is, so let's say innum. This is an int, so it can only take whole numbers. If I try to assign that to it, I will get an error. Okay, I will get an error because a byte short int or long can only take whole numbers. Now this guy here, this is a double. All right, this is something called a double. So what does that data type look like? So this will not compile as a int cannot have decimal places. Okay. Now, an int cannot have decimal places. So what I'm going to do is I am going to create something here, decimal places. So the first one we're going to use is a double. So I'm going to go double dnum is equal to 4.56. Double dnum is equal to 12.67. Dnum2. Okay. Now, so you can these are now numbers that can be treated just as ordinary numbers. So let's say I go dnum and dnum2 added is, so I go here, I go plus, I put them in their own separate brackets, I go dnum plus dnum2, it's going to give us 17.23. Okay, 17.23. Or you can do like we did with the ints, we can go double dsum is equal to dnum plus dnum2, and then we can say here sum of both doubles is plus sum. Okay, sum of both doubles. Hold on a minute now. Where is it getting 645? Oh, it's dsum. Okay, sorry about that. So it is dsum. Okay, 17.23. All right. Now, I'll just stop that a second. Now, there's another data type. Now, the important thing to remember is that all numbers with decimal places are by default a double. Okay, so there is another data type. It's called float. Now, a float, it's another type of number with a decimal place, but the difference between a float and a double is the following. As a double, if you do some calculation and you end up with 9.27778, say, okay, if you define it as a double, it'll always be that. If you have a float and you do the same calculation, you could get 9.27778 sometimes. Other times you could get 9.27777. Alright? What float means, exactly as it says in the tin, is that the value floats. Now it turns out for certain complex mathematical calculations, floats are preferred. However, for us as ordinary Java developers, it's debatable whether we need to use floats, unless specifically told to use them. So most of the time doubles will use fine, but you can use them. All right. Now the main thing about floats is, so let's say I go, so let's say float fnum is equal to 3.45. Now we're coming into the same problem as we came into with the long, okay? Because by default this is a double, okay? And a double is bigger than a float, okay? a double is bigger than a float. So it says right, this we treat it as a double by default. Hold on, a double is bigger than a float, so it won't fit inside a float. So what we have to do, if we want this to work, there's two things we can do. We can use something called casting. Okay, it's converting that guy into a double. Okay, or we can do this. We can just go fnum is equal to 3.45 f. Okay, both of those are so both of those are correct ways of doing it. Right, we can cast the double number 3.45 to be a float. Okay, we can put an f at the end of the number to tell Java this is a float. But if you do this, okay, this will generate an error. Generate an error as Java assumes 3.45 is a double, and a double is bigger than a float, so it can't be assigned to a float variable. Okay, so this will not compile. So I'll just comment it out. So you can see I'm not deleting code, I'm just commenting out code. Now obviously if something doesn't compile, you probably would delete that. But I'm talking about code that you might want to run again sometime in the future. Or maybe code that produces a mistake that you might need to refer back to that mistake for some other reason in the future. Right? It is possible you want to refer back to mistakes. Alright? You can learn stuff from mistakes. Now, so we have done the 6 numeric types. The reason I'm doing all these numbers to start off with is that everything in Java is based around these 8 primitive types, they're called. Alright? But the course is not Metsy. So let no one think this is going to be all Mets. It's not. Alright? It's, as I say, if you can follow a recipe, you can computer program. Right? I personally think it's a bit of a myth to say you need to be good at maths to be good at computer programming. No. Can you follow rules to their logical conclusion, even if it's daft where they're leading you? Then you can program. Alright? Now, so the next data type I'm using is something called a char. So, what is a char? Char stands for characters. Characters are single characters, and you use single quotation marks. Okay, so I'm going to add CHAR. Now Java is case sensitive as well, so it's not CHAR, it's CHAR. So char, my char, is equal to A. Char, my char2 is equal to lowercase a. Oh, sorry. By the way, it is single quotes. Sorry, not double quotes. Double quotes is something called a string. Okay, and we call this my char2. My char3 is equal to, so it can be, now a character is any symbol that can be typed on a computer. Okay, any symbol that can be typed on a computer is a char. Now when we're, so just print them off, so I go my char plus my char2 plus my char3. Right, so 225. Let me just see. I'll print off one of the chars only. another chair. Just give me a second now. I think I know what's happening here. Ah, yeah. So we just won't put that in for now. Okay, we'll just leave those aside for a second. Okay, so this prints off the character capital A. Okay, just prints off the capital character A. Now, it turns out, so a char is any keystroke you can do on a keyboard. All right, there's actually a lot of them. I'm using a Western European English keyboard. There is many different types of keyboards out there. All right, so there is, I think there's a couple of thousand of different keystrokes to produce particular characters. Anything to produce a particular character can be represented by these guys, char. Now, what happens is every time you click on, let's say I click on A, okay, or I click on capital D. All right. Now it turns out that the computer doesn't understand what D is. What it uses something called an ASCII key code. It uses a number to represent D. Now I know from trial and error before that if I do this, my char 4 is equal to 68. Now the number, so 68 is the ASCII key code for the character D. Okay, to prove that it is. There it is, D. So chars can take numbers, but they'll be displayed as whatever character it represents. Okay, so they can take numbers, chars can, but it's going to be displayed. That is what are called the ASCII key codes. It's hard coded into most electronic devices. All right, so when you press D, capital D, it's actually the number 68. So you can assign 68 to it. It will print off D. Now, you don't expect to know what each of the ASCII key codes. If you want to know, you just look them up online. Now, the last primitive data type, there's 8 in total, is a Boolean. Now, so let's see if I've done this right. So we go, this is Boolean. So Boolean, so I'll take this guy out. So I'll go Boolean, my bool. It can only be either one or two values, either true or false. All right. Now it can only either be true or false. So they're the only two values it can be. Now, by the way, as I've said already, Java is case sensitive. So it's not capital TRUE, it's lowercase TRUE. All right. So it is case sensitive. Okay. So what is this? Now, so if I just print it off, one of them, print off the word true. Now, that's not really how you use Booleans. What you use Booleans for, you use them for controlling if statements. You use them for controlling something called a switch statement. Oh, sorry, if statements, and use them for controlling loops. All right. How do you do that? So let's say we have a variable called age. And let's say this person is 16 years of age. All right. So as I've said, this means less than, this means greater than. This means greater than or equal to, this means less than or equal to. Okay, so I'm going to do here. So if I go age greater than 18. All right, now that equates to a Boolean. It's saying, is the age greater than 18? The answer is false. Okay, if I change the age to 21, is the age greater than 18? The answer is true. Okay, So I'm going to change that back to 16. That is what you use booleans for. Booleans are probably, along with ints and doubles, they're the main numeric types you'll be using. Okay, you'll be using doubles for wages and do with money. Now, sometimes you might have to use floats. Okay, so I'll take this out here, here. Ints, they're the majority of the time what you're going to use for numbers. Now you can use a byte for the age of someone, but now just use an int. Okay, and booleans, they're the three data types, three primitive data types you are going to use the most. Three data types you're going to use the most are going to be int for any whole number, the age of a person. They're, I'm trying to think. Okay, so the shoe size. Okay, their height wouldn't be an int; it'd be a double. 5'6". Okay, their wages would be a double. Now you use booleans as well. I will explain why you'd use booleans as well. Okay, so so we're going to do our second file, which we did last night, and I'm going to call this. Now, right click here, new Java project, and I'm going to call this chap 1.2, and I'm going to call this variables. I'm going to click on, so what did I put in there? I called it chap 1.2 variables. Okay. Click on finish. Excuse me. I don't want to create a module. Don't create. Now, so I have my new package here, or my new project, chap 1.2 variables. I right click on that, click on new, click on package. Same thing as before, com.android. Then I right click on com.android, I click on new, I click on class. I say main. Make sure you click on public static void main string args. There. Click on finish. Now, as you can see, we've got two files open. Alright? You can have as many files. Now, you will have a few files, but don't have too many of them open because it gets confusing. Right? So I'm going to close the original one, first one. This is our second one. Okay? Now, so we're going to go a couple of rules for creating variables. Okay, so variables by convention in Java begin with a lower case letter and use camel case notation. Okay, so let's say we want to have a variable that is going to be the name of, or the age of a person. All right, so we go int age of person, okay, equal to 23. All right, so that's all right. So age of person, or you could just say age person. Might be actually a little bit better because it's shorter. Or age of person, we leave it like that. All right, so camel notation, camel case notation means you start off with the lowercase a, and then because you can't have spaces in a variable, okay, so you can't have it at that, so we make every word that you would have in a little statement, instead of putting in spaces, we'll put a capital for each word. So you can see that's age of person. You can clearly say the O is capital O. You can clearly see the P is capital P. So, but if I do this instead, all right, that looks like it's Swedish. Age of person, or age of person. Okay, so whereas if you do this, clearly say age of person. Okay, so now always give your variable a name that means something. Okay, always give your variables a name that means something. Okay, don't, oops, I got this guy. So, don't use any of the following. So, I have these three. X. The only time I'd use X is if you're doing for positions on a grid. Okay, so X is along here, so you could say X, Y, Y is up that way. So the only time you use X and Y is for positions on a grid. All right, or something called YM, HY. What does that mean? Doesn't mean anything. Always give your variable, now keep them brief, but always give your variable a name that means something. Okay, you'd be surprised how often this shit is done. There's only one word to describe it. Okay, so don't do that. Give your variable name that means something, and also comment each one of your variables. Say what they are. So for instance, this is, even though, the age of a person. Okay, I have another one down here, int. You could also say person age, okay, is equal to 45, and you would say this is the age variable of a person. Okay, now, so what can variables, so we know the convention, it's lowercase. Now if you use something like so what you can't, so a variable can start with a number. Okay, so you can't have a variable that's called int 1 num. Oops, 1 num. Right, won't compile. Okay, will not compile, as you can't have a variable beginning with a number. Okay, however, you can put a number anywhere else in it. Okay, so you can't, you can go int num1, which is already seen, int, you can put a num1 um, they're all fine. Okay, so I'm just going to give them a value, 45, 67. Okay, you can use underscores. Okay, so int underscore number is equal to 56. You can use underscores at the end, is equal to 120. You can use underscores in the middle of it. You can use symbols. I wouldn't go using this symbol too much because it can lead to confusion. Dollar number is equal to 89. Int number dollar BER. I should be able to use star BER. No, actually, let me see if you can. Right, so you can't use mathematical symbols in the middle of a variable, as far as I know. You can use things like dollar. You should be able to use euro. Okay, so you can use monetary symbols when you have a variable, but you can't use mathematical symbols. All right, the general rule with variables is keep them simple. All right, keep them simple and easily understandable. You can use all of those things. Now, that type of variable with underscores, not used in Java really, but it is used in Python. So if any of you look up Python, you will see variables that look like that. But the usual sort of notation that's used with Java is that guy. That's called camel case notation. Okay. Now, so before we come on to casting, we're just going to show you a couple of things to do with numbers. Now, the reason I'm covering numbers to start off with is that everything you do in Java We're going to be coming on to arrays. We're going to be coming on to array lists. We're going to be coming on to sets, hash sets. We're going to be coming on to objects. We're going to be coming on to classes with generics. All of these are based on primitive variable or primitive variable types. The 6 number types, chars, and booleans. Everything in Java is based on those 8 data types. Alright, so now I can't stress enough, this course is not going to be all maths. It's just the first lecture really is the maths. The rest of it isn't really going to be maths at all. Okay, now so let's say we have a double is equal to 45.6. By the way, you don't have to give a value to a variable either. Okay? You don't have to give a value to a variable on the first line. You can give it on another line if you want to. Okay? So you can give variables a value on a different line than from where they were first created. Now that's not the case with all programming languages, but it is the case in Java. So we can see there, I created a variable called dnum, and then I gave it a value of 45. All right. So 45.2. Oops. All right. Now, so where am I? All right. So sorry about that. Just give me a second. Now. So here we have double dnum is equal to 45.2. Now you can also assign an int to a double. So I can say 4. Alright, that is fine. Why? Because an int is smaller than a double. So an int can easily fit inside a double. So put in here. First of all, you can create and assign a value to a variable over 2 lines if you like. Okay, you can assign a int value to a double variable as a int is smaller than a double, so it can be assigned to a double. Now, if I print off the double here, it will print off 4.1. Okay, so what it's doing is it's taking 4, it's assigning it to here, and it will create a double called 4.0 out of the number 4. Now it's the same value, but it's showing you that you can assign a int to a double. Now as well, if I create int num and I say dnum, so what's that doing? That's assigning the int num to dnum, which you can do. And then I go to print off. Dnum is now plus dnum. Prints off 5.0. So here again, you can assign an int to a double as an int is a smaller data type than a double, so it can easily fit inside a double. Now you can't do the other way around. Okay, if I go num is equal to 3.14, 3.4 will not compile. As a double is too big for the int num. Okay, so that won't compile. This also won't compile. num is equal to dnum. Now dnum is the value 5.0. Okay, so again, this will not compile, as dnum, as the double dnum is too big for the int variable num. Okay, so neither of them will compile. Now we're leading on to something called casting, but before we get to that, I'm going to show you what is often a mistake that people make, okay, with programming. All right, so I am going to say num is equal to 10. Okay, int num2 is equal to 6, isn't it? Yeah, 6. Num2 is equal to 6. Now, before I do this, I am going to take two doubles. All right, so I have dnum is equal to 10.0. Oops. I'm going to go double dnum2 is equal to 6.0. Now I'm going to print off SYSO. So dnum, or so 10.0 divided by 6.0 is, so I go plus, I put in my bracket, and I get dnum divided by dnum2. Okay. Now we see we get 1.66666666666. Okay. Right. So now these have the same value. That's the same value as that. That's the same value as that. But this guy is a double. This guy is a double. Now these are ints. Watch what happens when we divide ints. Alright? So now this is integer division. It's called. So dividing 10 by 6 is, oops, just turn off that lid, is, so I go plus, I get num divided by num2, we get 1. Now there's a bit of automatic casting going on here. What actually happens is you have 10 divided by 6. Now when you divide two ints, the answer is always an int, and you can't have decimal places in an int. So what happens? It chops it off. Okay, so this produces here, we know when we divide these numbers, it gives us that. Okay, now this guy here, when you divide two ints, you are using integer division. Okay, and oops, and as we already saw, 10 divided by 6 gives us that. However, when you divide two ints, the product, the answer, is also going to be an int. So it can't display that. So it simply chops off the 1.6667 part to become 1. Okay, now you need, when you do that, just be cognizant of it. Alright, if you are going to division, there is going to be times you need to do division. Alright, if you are going to division, use doubles. Alright, now you can set the decimal places not to be that long. There is other methods that allow you to divide and only give you 2 decimal places. Alright, but that's a bit more advanced. We're not going to do that yet. So if you are going to do division, make sure you use doubles. Don't use ints unless you want to get a number like that. Alright, there is going to be circumstances when you want to get a number like that. Now, casting. So what's casting? Casting, put in here, casting is changing from one compatible data type to another. So it's changing from one number to another. Alright, so let's say we want to cast double to be a float. So dnum is equal to 9.99999. Okay, so I'm going to go int number is equal to, now you can do this, int dnum, oops, I already have number, okay, number 1, I already have as well, no, okay, so now what that does is, it does the same as the integer division. This will chop off the 0.99999 and you end up with just 9. Okay, so if I print off number, you'll see it prints off 9. Okay, prints off 9. Now, as I've already said before, now this is just briefly covering casting. We will come back more to casting. Right? We will come back more to casting. But we're going to come back towards in the context of casting different objects, which is a different thing. Alright? We're not going to really do much casting with numbers, but we're going to be doing casting with what are called objects. Alright? But before we go, let's say if we want to, which I showed you in the previous file about floats. Okay? So, if you want to use floats, you have to cast it. Basically. Now, so as I've already said, if you have a float, and if I just say that, that will not compile. Okay, will not compile because every number with a decimal place by default, decimal place by default in Java is a double. So, and a double is bigger than a float. Okay, so 56.78 Java treats as a float, and we can't assign, treats as a double, sorry, and we can't assign a double to a smaller reference, which is float. Okay, so what we need to do is we need to tell Java that this is not a float, that 56.78 is not a float. You can do this by casting. Okay, so I'll comment that guy out. Go on to the next line. I'll go float fnum is equal to, so FLOAT 56.78. Okay, so now it's a float, or alternatively you can go float if num2 is equal to 578.99f. Okay, so this will also cast it. Tell Java that this number is a float. Okay, now let's say I didn't cover this yesterday, but I probably need to. So let's say I create a byte. Num is equal to 78. Okay. Now you can cast that to a bigger number type. All right. So let's say we have an int, and I just call this number 2 is equal to 56. Right? And if I go byte bnum is equal to number 2. Right? That won't compile. Why? Because an int is bigger than a byte. Now, if we cast number 2 to be a byte, all right, what does that print off? It should work, I think. Okay, now that's fine as long as the number is less than 128. If I make my number 306,000, okay, prints off 112. All right, let me just try what is the highest number you can go to. 120. Okay, 127. 128. Oops, sorry. Alright, now here's the thing, right? So you can cast an int to be a byte as long as the number you're casting is less than 128. If it's bigger than 128, alright, your results are totally, well, not totally unpredictable, because a byte can only hold plus minus 128. If you go above it, it will try to display it within the numbers 128 minus 128 plus 128. Now I think what it does is the following. Let's say if I put in 128. Now that can't be displayed as a byte. Alright? So what it does is it goes to minus 128. If I go to 129, it'll go to minus 127. Okay? And it keeps going up. Alright? But it's not a real number. Okay? So it all goes to say beware of casting. Okay, and do not use it too much. If there is an alternative way to do something, then do that instead of casting. It's not good practice to use casting too much. Okay, only use it if you absolutely positively have to. My advice is don't use it. All right, because you can end up with, let's say, this sort of thing here, within 6,000. You try to cast 6,000 to be a byte, it becomes 112, which is really, you have no way of getting back to 6,000 from that number. Okay, 6,000 can't be displayed. So it will try and display some number, which in this case will be the number 112. 6,000 can't be displayed, so this is too big for a byte. So if you just try to that won't compile. Okay, so we can try and cast it. Thing is, if you cast it, what you end up then with is, instead of 6,000, you end up with 112, which bears no relationship to the real number at all. So casting for floats, yes, but I'd use that instead of using that guy. All right, but I wouldn't advise you to use it unless you absolutely positively have to. Okay, casting also shows that you haven't thought through the full implications of what you're programming. All right, because remember when I said to you before that computer programming is 90% preparation and testing, 10% actually coding. All right, so you have all your variables done out on this. You start off with a piece of paper, then you progress on to something called UML. UML is just diagrams, right? So diagrams. You have your complete program diagrammed to within an inch of its life, even down to the level of seeing what variables you're going to have. All right, and if you start casting variables in the middle of the program, it shows you haven't. It shows you haven't thought through things. Okay, all right. So casting is fine, but I would stay away from it if at all possible. All right. Now, so then I just briefly covered objects. All right, so we have the 8 primitive data types. Okay, there's only 8 of them. So byte, short, int, long, double float, char, boolean. Now, but mainly what we're going to be dealing with in Java is these guys, something called objects. Now, we won't be covering them even next week, but I'll just briefly introduction to them. Okay, so Java is a object orientated programming language. Okay, now the objects are made of something. Okay, and all objects are made up of primitive data types or other objects. But those other objects, eventually everything is made up of these 8 things. Okay, they are the foundation stones of all objects in Java. Now, what's an object, and what is an object in real life? An object can be a place, a person, or a thing. Okay, it can be something you can physically touch. An object can also be, in computer programming, can be something like an idea. A bank account is an object. Your wages is an object. Your career is an object. Your education could be said to be an object. Okay, so Java is an object-oriented programming language, but at the end of the day, all objects are made of these guys here. Now, we've already come across one object already. All right, this guy, Harry. Ferguson. Okay, now, so I'll put it in here. And I go here, that this, is not a primitive data type. This is an object type. The object type is string. Now it's uppercase string. Now Java is case sensitive, so it's not this guy. That's incorrect. It's also not this guy. That's incorrect as well. Okay, so Java is case sensitive, so string name. Okay, another one. It's capital string. String address. I'm going to say my address. Okay, so now strings, what are strings made up of? Strings are a list of chars. Alright, so what I'm saying is that all objects in Java are made up of other objects. In the case of a string, all it is, it's something called an array. Okay, it's a list. An array is a list. That's what it is. So it's an array of chars. Now, obviously it's going on in the background. You don't need to know the mechanics of it. So there's something called a class. It's a string class. Alright? And the string class is made up of an array of chars. So every string is made up of an array of chars. You can even have more complex objects. So this is something called an array list. It's a list. Okay? Now, I don't expect you to know this. So I just need to import. Oh shit, wrong one, sorry. Wrong one. It's not it, I want a T. So just bear with me a second. It's this one, JavaUTL. Import array is JavaUTL. Now, so this is a lot more complicated object, obviously. Alright? Now this is something called a list. And it's exactly as it says in the tin. It's a list of objects. Okay, it's a list of objects. Now it's a list of strings. No paddy. See, remember the commas? Separates each string in our list. Noel, Paddy, Kate, Mary, Sharon. Okay, so there is 5 strings, and each one of those 5. So this is a list of 5 strings, and each one of those strings is made up of, in turn, a char. Alright, so I'm saying it doesn't matter how complicated the object is, eventually they're all made up of these 8 data types which you have up there. Now, we will actually be doing that. You will understand that. Now, it won't be for the first 2 or 3 weeks, but you will understand that. Alright, this is using something basically on the right hand side called functional programming. Alright, we will be covering functional programming in this course. Okay, now if you want to print off this list, which is a list of names, I just quite simply go SYSO names, and it'll print off all those names. Okay, so nothing too complicated there. Now the last thing we did Thursday night was you can declare multiple variables on the one line. So let's say int number 4 is equal to 56, number 5 is equal to 120, number 6 is equal to 899. Okay, so you can declare multiple variables of the same type on the same line. Okay, but they have to be the same type. They can't be different types. Okay, so I can't do, let's say, double D number is equal to 45.6, and then we have a number int number 7, number 8 is number 7 is equal to 99. Can't do that. Alright, can't do that, so that will not compile. Can't be different types, will not compile. Now, so if we have a string, so I'm going to create a couple of strings. String name 1 is equal to my good father's name, Paddy. Name 2 is equal to my good mother's name. Good Irish names. Okay. Now, just the last thing to say about variables is when you're declaring variables, when, if at all possible, you should declare them at the top of your file. Okay, so you should really declare them up here. All right, because it's easier. Then you don't want to be looking through your code for variables that could be anywhere. So where you usually put them is at the top of your screen, or the top of your method. Okay, we're inside the main method, so ideally you'll want to put the methods you're creating variables, you put them up at the top of your file. Okay, here, top of your method, ideally. But as I said, we're going along learning, so we have to be creating variables as going along. But you ideally put them up here at the top. Okay, it's purely because then you won't have to be scrolling up and down looking where your variables are. Okay, now you do have tools here. You can, I'm trying to see which one it is. There's a tool here that will display all your variables. I can't remember what it is, but it is there. Okay, but even at that, you're better off to try and have all your variables at the top of your screen. But when we're learning, we have to be writing variables as we go. Now, so that's the video for the first lesson done. So we'll see you all again on next Wednesday. Bye.